So good morning students. Now we'll see the last topic under your module 4, that is transform of basic R, L and C elements. So here we are going to have your resistance R, where a resistance R is going to be represented by this symbol. The current through the resistance is going to be I of t and the voltage across the resistance is going to be V of t. So if you are going to take the Laplace transform of this function, it is going to be current I of t is going to be your I of s and V of t is going to be your V of s, and this is going to be your resistance R. So I can write V of s is equivalent to I of s into R. So from this, if I write Z of s is equivalent to V of s by I of s, that is nothing but R, where Z of s is going to be the transform impedance in frequency. So S is going to be in terms of your frequency there. So Y of s is equivalent to 1 by Z of s, where Y of s is nothing but the transform admittance. Next is inductor. So inductor, we can write it as your voltage across the inductor is going to be V of t is equal to L into di of t by dt. So if I am going to take the Laplace transform, it is going to be V of s is equal to L into Laplace transform of di of t by dt is nothing but s into I of s minus I of 0 minus the initial condition. So here in this case, we are going to have your voltage, your s into L into I of s minus L into I of 0 can be written as your expression here. So here that is going to be your L into this one. So here if I am multiplying it, it is going to be L into S into I of S minus L into I of 0 minus. This I can represent, the voltage across the inductor can be represented as this equation there, where your inductor is going to be S into L, the current through the inductor is going to be I of S minus your initial voltage, the initial current is going to be L into I of 0 minus, or you can write as L into I of 0 plus if I am assuming your initial current to be your I of 0 plus. Anyway, I of 0 plus is equal to I of 0 minus there. Because the current in the inductor cannot change instantaneously, I can represent as L into I of 0 minus or L into I of 0 plus. So next is your I of t. The current through the inductor I of t can be written as 1 by L integral 0 to t V of t dt plus I of 0 minus there. So if I take the Laplace transform, your Laplace transform of I of t is nothing but I of s plus is equal to 1 by L V of s. Laplace transform of the integral is nothing but V of s by s plus I of 0 minus by s there. So I can represent the equivalent circuit as you are going to have your current through the inductor is going to be V of s divided by s into L, and if initial current can be written in parallel, that is going to be your I of 0 minus or I of 0 plus by s, that is the initial current through the inductor there. So your total I of s is nothing but the combination of these two. So we can write the sum of the incoming currents is equal to sum of the outgoing currents. This is the equivalent representation of your I of s. Next is your capacitance. So your capacitance V of t is equivalent to 1 by C integral 0 to t I of t dt plus Vc of 0 minus. So V of s is equivalent to, if I take the integral value, it is I of s by sc plus Vc of 0 minus by s. So I of t is equivalent to, so here in this case this is the voltage across the capacitance. So I can write your voltage across the capacitance is nothing but 1 by Cs. So voltage across the capacitance is written as 1 by Cs, and this your initial voltage can be written as V of 0, Vc of 0 minus by s. So the current through this capacitance is going to be your I of s. So this is your equation circuit for your voltage V of s. Next is your I of t. So I of t is equivalent to current through the capacitance is C into dV of t by dt. So if I take the Laplace transform of this, it is going to be I of s is equivalent to your C into your Laplace transform of this is your S into V of s minus Vc of 0 minus. So if I multiply it, your I of s is equal to S into C into V of s minus C into Vc of 0 minus. So I can write sum of incoming current is I of s. Your outgoing currents are going to be, one is the capacitance current, that is your Vc of s, that is your V of s by 1 by Cs, and next is your capacitance. Here the voltage is going to be C into Vc of 0 minus or C into Vc of 0 plus, because The voltage across the capacitance cannot change instantaneously. We can write V of 0 plus or V of 0 minus. So we'll see a problem here. For the circuit shown in figure below, the steady state is going to be reached with 100 volt source. At t is equal to 0, the switch K is going to be open. What is the current through the inductor at t is equal to half second there. So in this we are going to see that your steady state condition. So steady state condition means when the switch is going to be closed, that is 0 minus condition. So steady state means your inductor will behave like a short circuit there. So when the inductor behaves like a short circuit, my circuit is going to be like this. So when my circuit is going to be like this, I want to find out what is going to be the current through the inductor. To find out the current through the inductor, what we are going to do is, we are going to find out the total current. So to find the total current, I am going to draw the equivalent circuit. So your equivalent circuit is going to be, this is plus minus, this is going to be your 100 volts. You are going to have your two resistance to be in parallel. So it is going to be your 40 into 40 divided by 80. So that means that this is going to be 2, here it's going to be your 20. So your total resistance is going to be 20 ohms. Now I want to find out what is going to be the total current that is going to flow through the circuit. Your total current is nothing but I is equivalent to, your voltage is nothing but your 100 divided by your resistance is going to be 20. So 100 by 20 is going to be 5 amps. So the total current that is going to flow through the circuit is going to be 5 amps. Now if I know the total current, I can find out what is going to be the current that is going to flow through this inductor there. To find out your I2 of 0 minus, I can apply my current divider rule. So your I2 of 0 minus is equivalent to your total current. Your total current is nothing but 5 amps into opposite resistance is going to be 40 divided by your total resistance is going to be 40 plus 40. That is 80. So here in this case we are going to have this 40 and this 40, this one will get cancelled and I will be getting it as 2. So 5 divided by 2 is nothing but 2.5 amps. So we have your I2 of 0 minus to be 2.5 amps there. So next is we are going to have the switch to be moved to your position 2. So when the switch is at t is equal to greater than or 0 plus, my switch is going to be in the closed position. So here in this case, your switch, when the switch is in this case, your switch is going to be in the open position. So t is equal to 0 plus, my switch K is open. When it is open, this part of the circuit will not get connected. So here when the switch is open, this part of the circuit will not be available, only I will be having this part of the circuit there. So we draw the circuit as at t is equal to greater than or 0 plus, my switch is open and I am going to have a circuit like this. So when I am going to have a circuit, I want to find out what is going to be the current that is going to flow through the circuit. So your I of t is nothing but 80 ohms. Here in this case it is going to be 4 henries there. So I can have the expression as 80 into, if I write the equation, it is going to be 80 into I of t plus 4 into di by dt is equal to 0. Now I want to find out your I of t there. So first take the Laplace transform, 80 into I of s plus 4 into s into I of s minus I of 0 minus. Laplace transform of di by dt is nothing but s into I of s minus I of 0 minus there. So if I expand this expression, 80 into I of s plus 4s into I of s, this is minus 4 into I of 0 minus. If you bring it to the right side, it is going to be 4 into 2.5. That is nothing but divide throughout by 4. If I divide this equation throughout by 4, this is going to be 20 into I of s plus s into I of s is equal to 2.5. So I of s is equal to 2.5 divided by s plus 20. If I take the inverse Laplace of it, I of t is equal to 2.5 into e power minus 20t. So now they have asked in the problem at t is equal to 0.5 second, what is your I of t? So substitute t value to be 0.5. So I of 0.5 is equal to 2.5 into e power 20 into 0.5 is nothing but 10. So e power minus 10. So if I find out e power minus 10, the value is going to be 1.135 into 10 power minus 4 amperes there. So this is your first problem. So second problem is using Laplace transform, determine the current in the circuit shown in figure below. When the switch is going to be closed at t is equal to 0 plus. Assume 0 initial condition. So in a problem itself they are given that your initial condition is going to be 0. That means you are going to have your inductor to be your open circuit. So I of 0 minus is going to be 0 there. And your Vc of 0 minus is also going to be 0 because no current flows. Your voltage across the capacitance will also be 0 there. So now If I write my basic equation, your basic equation is going to be your 100 by s. So if I take this Laplace, convert it to your s domain, this Laplace transform of this 100 volts is going to be 100 by s, and this 2 ohms is going to be just 2, no change. This inductance is going to be s into L. L value is 1, so I write it as s. And capacitance is 1 by SC, 1 by C value is 1, so it is 1 by S. Now I'll write my KVL equation. When the KVL equation is 100 by S is equivalent to 2 into I of S. The current through this is I of S. So 2 into I of S plus S into I of S plus 1 by S into I of S. So here I can take out your I of S outside. So my expression is going to be Y of S into 2 plus S plus 1 by S. So 100 by S is equivalent to I of S into, if I take the LCM, it is going to be 2S plus S square plus 1 by S. So I can write my I of S is equivalent to 100, this S and S gets cancelled, so 100 by 2S plus S square plus 1. So this is nothing but S plus 1 the whole square. So I can write your I of t is equivalent to 100 into E. This is nothing but you are shifted by 1, so it is your e power minus t. S square is nothing but t, so t into e power minus t amps. So I of t is equivalent to 100 into t into e power minus t amperes there. Thank you.